As we all know, it's our duty to guide the farmers about the recommended dose of nitrogen, phosphorus, and potassium. So, what is fertilizer calculation? How we can calculate the amount of fertilizers per hectare by following the recommended dose, which is in the form of N, P, and K. I am Dr. Muhammad Amin. In this video, I will tell you about how to calculate the amount of urea, SSP, and MOP for an area by following the recommended dose in the form of N, P, and K. In this question, we have three sources: urea, SSP, and MOP for nitrogen, phosphorus, and potassium. As we all know, 1 hectare is equal to 2.471 acre. So, because of the similar dose of nitrogen, phosphorus, and potassium for 1 hectare, so we should have just only to calculate the amount of urea in the following way. As by unit method, we all know 46 kilogram of nitrogen is present in 100 kilogram of urea, and 1 kilogram of nitrogen is present in 100 divided by 46 kilogram of urea. Finally, 120 kilogram of nitrogen is present in 100 divided by 46 multiplied by 120. So 260.86 kilogram of urea should be required for 1 hectare. Similarly, the amount of SSP should be calculated, whereas before calculating the amount of SSP, we should convert the recommended dose of phosphorus into P2O5 by multiplying with a factor of 2.29. So in this case, the recommended P2O5 should be equal to 91.6 kilogram. So again, 18 kilogram of P2O5 is present in 100 kilogram of single superphosphate. 1 kilogram of P2O5 is present in 100 divided by 18, and 91.6 kilogram of P2O5 is present in 100 divided by 18 multiplied by 91.6. So the answer is 508.88 kilogram of single superphosphate per hectare. In case of MOP, we should calculate, whereas before calculation we should convert required amount of potassium into K2O by multiplying with the factor of 1.2. So it should be equal to 48 kilogram per hectare. Again, 60 kilogram of K2O is present in 100 kilogram of MOP. 1 kilogram of K2O is present in 100 divided by 60 kg of MOP, and 48 kilogram of K2O is present in 100 divided by 60 multiplied by 48. So 80 kilogram of MOP per hectare should be required. At the end, we conclude as we shall add 5 bags and 11 kilogram of urea for nitrogen, 10 bags and 9 kilogram of single superphosphate, 1 bag and 30 kilogram of MOP provide nitrogen, phosphorus, and potassium respectively. The question second is how much amount of urea, TSP, and MOP is required for 300 square meter for the same recommended dose. So in this question, recommended dose is same as used in the first numerical, whereas the difference is only area. In this case, area is 300 square meter. Again, all the sources are same: urea, TSP, and MOP. In this question, just only TSP is different from the SSP which was used in the first numerical. All the method is same. However, in the first numerical, the recommended dose is for 1 hectare, and we should have no need to calculate required amount of nitrogen, phosphorus, and potassium for our required plot area. However, in this case, first we should calculate the amount of required nitrogen, phosphorus, and potassium for our concerned area, which is 300 square meter in this case. So first we write 10,000 square meter area required nitrogen, 120 kilogram of nitrogen. By unit method, we should write 1 square meter area required nitrogen, 120 divided by 10,000 kilogram of nitrogen, and 300 square meter area required nitrogen, 120 divided by 10,000 multiplied by 300. So 3.6 kilogram of nitrogen for our plot area should be required, and we should calculate the amount of urea in this way. 46 kilogram of nitrogen is present in 100 kilogram of urea. 1 kilogram of nitrogen is present in 100 divided by 46 kilogram of urea. 3.6 kilogram of nitrogen is present in 100 divided by 46 multiplied by 3.6, and it should be equal to 7.8 kilogram of urea per plot. Now after nitrogen, we should calculate the phosphorus with a similar method. First we should calculate required amount of P2O5 for our plot, and then we should calculate the amount of triple superphosphate or any other concerned fertilizer. So 10,000 square meter area required 91.6 kilogram of P2O5, 1 square meter area required 91.6 divided by 10,000, and 300 square meter area required 91.6 divided by 10,000 multiplied by 300, and it should be equal to 2.748 kilogram of P2O5 per plot. Now 46 kilogram of P2O5 is present in 100 kilogram of TSP. 1 kilogram of P2O5 is present in 100 divided by 46 kilogram of TSP. 2.748 kilogram of P2O5 is present 100 divided by 46 multiplied by 2.748. 5.97 kilogram of triple superphosphate for our plot area should be required. At the end, total required K2O should be calculated in this manner. 10,000 square meter area require 48 kg of K2O. 1 square meter area require 48 divided by 10,000 kg of K2O, whereas 300 square meter area require 48 divided by 10,000 multiplied by 300, and it is equal to 1.44 kg of K2O. To fulfill this required amount of K2O, we should calculate the amount of muriate of potash as follows. 60 kg of K2O is present in 100 kg of MOP. 1 kg of K2O is present in 100 divided by 60 kg of MOP, and 1.44 kg of K2O is present in 100 divided by 60 multiplied by 1.44. So 2.4 kg of MOP or muriate of potash for our plot area should be required. We conclude as for 300 square meter area we should have to add 7.82 kg of urea, 5.97 kg of TSP and 2.4 kg of MOP for our plot area. In question 3, the only difference is our plot area, which is 500 square meter, and the second different thing is our recommended dose, which is 175 and 50 kg per hectare NP and K respectively. So again, first we should calculate the amount of nitrogen required for that area. 10,000 square meter area require 100 kg of nitrogen. 1 square meter area require 100 divided by 10,000 kg of nitrogen, and 500 square meter area require 100 divided by 10,000 multiplied by 500, and it is equal to 5 kg of nitrogen per plot. So we should calculate the amount of urea now. 46 kg of nitrogen is present in 100 kg of urea. 1 kg of nitrogen is present in 100 divided by 46 kg of urea, and 5 kg of nitrogen is present in 100 divided by 46 and multiplied by 5. So 10.86 kg of urea for our plot area should be required. After nitrogen, we should calculate the phosphorus with a similar method. Before calculation, we should convert phosphorus into P2O5, and in this case it is equal to 171.75 kg of P2O5. So 10,000 square meter area require 171.75 kg of P2O5. 1 square meter area require 171.75 divided by 10,000, and 500 square meter area require 171.75 divided by 10,000 multiplied by 500. It is equal to 8.58 kg of P2O5 per plot. Now 18 kg of P2O5 is present in 100 kg of single superphosphate. 1 kg of P2O5 is present in 100 divided by 18 kg of SSP, and 8.58 kg of P2O5 is present in 100 divided by 18 multiplied by 8.58. 47.6 kg of single superphosphate should be applied to fulfill a recommended dose of 171.75 kg of P2O5. Similarly, K should be converted into K2O by multiplying with the factor of 1.2. So 60 kg K2O is required for our per hectare basis. 10,000 square meter area requires 60 kg of K2O. 1 square meter area require 60 divided by 10,000 kg of K2O, and 500 square meter area requires 60 divided by 10,000 multiplied by 500. 3 kg of K2O should be required for our plot area. 50 kg of K2O is present in 100 kg of sulfate of potash. 1 kg of K2O is present in 100 divided by 50 kg of sulfate of potash, whereas 3 kg of K2O is present in 100 divided by 50 multiplied by 3. 6 kg of sulfate of potash for our plot area should be required. So we conclude that we have to apply 10.86 kg of urea, 47.66 kg of single superphosphate, and 6 kg of sulfate of potash for our plot area. In this numerical problem, rest of the method is same, area is also same, whereas recommended dose is different from the previous question. In this question, it is equal to 120, 65 and 45 kg per hectare for nitrogen, phosphorus and potassium, and we have three sources: urea, single superphosphate and sulfate of potash. So first we should calculate the required amount of nitrogen required, which is 6 kg in this question. After that we should calculate the amount of urea, which is equal to 13.04 kg. After nitrogen we should calculate the phosphorus with a similar method. First we should convert phosphorus into P2O5, which is equal to 140 48.85 kilogram. After that, we should calculate the required amount of P2O5 for our plant area, which is equal to 7.44 kilogram of P2O5. Then we should calculate the amount of single superphosphate, which is equal to 41.33 kilogram for our plot. Similarly, first we should calculate K2O required for our plot, and it is equal to 2.7 kilogram of K2O. To fulfill 2.7 kilogram of K2O, we should apply 5.4 kilogram of sulfate of potash for our plot. In question 5, all the method is similar. The only difference is its recommended dose again for nitrogen, phosphorus and potassium, which is 200, 220 and 110 kilogram per hectare respectively for nitrogen, phosphorus and potassium. Three sources should be used: urea, SSP and sulfate of potash. Again, we require 10 kilogram of nitrogen, and which will be fulfilled by applying the 21.73 kilogram of urea for a plot area of 500 square meter. After nitrogen, we should calculate the phosphorus with the similar method. 25.19 kilogram of P2O5 is required for our plot, and 139.9 kilogram of single superphosphate should be applied to fulfill this dose of P2O5. At the end, total required K2O should be calculated in this way. 6.6 kilogram of K2O is required for our plot area, and by following this dose, we should calculate as follows: 50 kilogram of K2O is present in 100 kilogram of sulfate of potash. 1 kilogram of K2O is present in 100 divided by 50 kilogram of SOP, and 6.6 kilogram of K2O is present in 100 divided by 50 multiplied by 6.6. So 13.2 kilogram of sulfate of potash for our plot area is required. So we conclude we shall add 21.73 kilogram of urea, 2 bags and 39 kilogram of SSP and 13.2 kilogram of SOP for an area of 500 square meter. Thank you very much. If you have any question, please like, share and comment, and I will prepare your concerned videos. And if you want to learn about any information, please comment me in comment box.